material modeling simulation. Today we will write up the SIESTA input file, how to write, and how to all the parameters which is required for the input file. So in lecture 7, I showed you how to model the structure. So in the Material Studio library, we import the silver bulk structure or bulk cell, and we import that structure with this is the silver cell, and we import it in PDB format, and that PDB format actually we visualize in the VND, visual multiple dynamic simulation here, and we import here you can see that how to import XYZ, and we can save in the XYZ format. This file actually, when we proceed in Vista, it showed wrong number of atoms, but I already showed you that here this Vista generated XYZ coordinate shows 14 number of atoms, while actually this unit cell has 4 number of atoms, which VMD correctly produced. So here you can see this 4 represents the number of atoms in this structure. And here we write up this SIESTA input file. So here you can see that system level. The system level, I'm working on silver bulk structure, so I use silver bulk. And optimization method is MD type of CGB conjugated gradient. And MD steps, number of conjugated steps, 900. So this structure can be optimized in less number of steps, maybe 10, 20, 50, 100, or 200. And the MD variable cell is true. This means that the latest vectors, these latest vectors can be changed during the optimization in order to achieve the ground state energy. So this ground state energy I will show you in the output file that why it is ground state energy we call it. And SCF, so solution method is the diagonal method, and the iteration from if you know about the steers. So from step 1 to step 2, the certain distance we travel and place our foot on the second step. So the same is this SCF iteration is the convergence criteria from step 1 to step 2. And spin polarization, in this case, I make it false. If you want to calculate, then you need to write it here capital T, or you need to write up the true. And mesh cutoff is the energy cutoff, which is the 200 RY. So below and above, all the energy will not be included in the output file. The functional here is the exchange correlation function. We use the generalized gradient method, and the exchange correlation occurs the revised curve for unzero method, which they write of this method. And long output true means that it will by default how many number of output files, different output files, it will print out the direction. And here is the K grid. So for the unit cell, because of no vacuum in the unit cell, so I place here this number 3 along the C axis. But if we include vacuum, and so vacuum we include in any structure when we are going to interact with interact the surface with other molecules or atoms or any type of material. Okay. And here you can see that the number of species, so it is only silver, so the number of species is 1, and number of atoms in this structure is 4. So it is divided by 4. Here is the atomic symbol or the chemical species label. So we give this, this is 1. 1 is the representation for this silver, and 47 is the atomic number. And PAO means zero atomic orbital. So we apply for this calculation double zeta potential DCP. while single zeta potential people also use, the web calculation is actually low quality. So, and you can also include the constraint, put constraint on your structure, but here we don't need to. And for that reason, I place the comment, I use the hash number, which means that it will tell the SIESTA that this is not calculated. No need to calculate it. And latest constant, so you know that this is the cubic structure, so A is equal to B, A is equal to B is equal to C. So this means that either you can place the letter filter here, and here you can mention 1. If you place this latest vector here as the latest constant, then here you need to 1, 1, and 1. And these are the atomic coordinates, the atomic positions, and this is the 1 which we represented silver as the 1, and which is the 1 actually, and this is the symbol, and this is the serial. Okay. So this we will submit this. Let's try to submit this job in the SIESTA. So here I created the CD bulb. Okay, here you can see. So first I will copy this SIESTA executable to the bulb structure. Here you can see CD bulb. Okay, so here you can see that the executable is here. So now I want to submit this job. So SIESTA and bracket silver, okay, input file, and silver. This is the input and output, and I should I can give different name or the same name. And M%, this M% is basically it will run this job in the background, not in the foreground. If you don't mention this M%, then you cannot use this terminal for any other purpose. But once we write this M%, then we can use the same terminal for other purpose. So here you can see, so this is the job ID for this simulation, and we can see that whether the simulation is running or not. So here you can see now this job is running, and it is, these are the different output file it creates, like silver bulk bond, silver this KP, silver RA structure, XV, XYZ, and this is the input file, and this is the output file. So ls minus L will tell us about the output file size in bytes. Okay? So here you can see 19420 bytes is the size of this file. Okay. Let me check here again. You see now this size is again increased. So this means that the simulation is writing in the output file, and tail silver that out, so it will show, give us the information at the end of the output file what is here inside. So here this job is running, and once it is completed, then I will show you that what kind of other files and animation files it can produce. Okay? So here you can see now this silver bulb.cg conjugated gradient is created, density matrix is created, and this is force related, and this is MD coordinates, MD Cartesian, sorry. And so, and here you can see this animation file is started to create. So if we check it, then the first step will be written here. Silver in silver, so you can see one, two, three, four, five, and 5 steps. This job first step is written in the animation file. So this is all about this job. Once it is completed, then I will show you that.